Since most of you depends on question paper, so and even the time is less, so it will take time for me to do the lectures on other modules. So right now I'll just solve this model question paper, first model question paper. Okay, so we will go with module 1, first part 1. They have said show that P implies Q and Q implies R and R implies P. Just not implies, this is biconditional. It is logically equivalent to P implies Q and Q implies R and R implies P. Okay, for permutation PQ are logically equivalent. You have to show that it is logically equivalent or not. First what I will do, I have to use table here. Okay, PQR. Okay, 0 0 0 0 1 1 1 1 double 0 double 1 double 0 double 1 0 1 0 1 0 1 0 1. Now first what I will do, I will take P implies Q. Okay, so I will take this P implies Q. What is the answer? 0 implies 0. This is, see, if both are true, then only this will be true, right? I had explained that thing. So wherever I have P and Q both are equal, there I will just write 1. 0 0 here 1. Then remaining all, this is 0 0 0 0 and last 2 is 1. Similarly, Q implies R. Here wherever I have 2 zeros or 2 ones, I will just write 1 over there. This is 0 0 1 1 0 0 1. Similarly, I will write for R implies P. This I have to take. So first one 0 0 is correct, 0 1 wrong, 0 0 correct, 0 1 1 0 1 1 1 0 1 1. Then I'll find I have to take this and this. Suppose this is I have kept I, this is I have kept 2. I'll write I and this 1 and 2. Okay, then this is 3. You keep assume, because it will take a lot of space. Just understand this and this I am doing. Okay, 1 into 1 is 1 1. So wherever 0, I'll just write 0 0 0 0. This is also 0 0 1. Only first and last I am getting 1, remaining all are zeros. Okay, then suppose this is 4, so I multiply 3 and 4, this and this, because this R implies P, right? So even this whole thing I found. Now this thing into this thing I have to do. So again, only first will be 1 and last will be 1, remaining all will become 0 itself. Okay, shall I erase this? I will write it like this here, because I need space, right? So only first and last is 1. So I will erase this. In exam, if you are not getting space like that, just go down and create another column. So this thing I will do like this. Okay, so it was 1 0 0 0 0 0 0 1. Okay, I will write LHS here, but actually you have to write this whole thing itself. Now I will do this. P implies Q. 0 implies 0, true. 0 implies 0 is true. 0 implies 1 is also true, true. Only where it will be false, where greater it is decreasing, 1 to 0 1 to 0. Then true, true. Then Q implies R. 0 0 correct, 0 1 correct, 1 0 wrong, 1 1 correct, 0 0 correct, 0 1 correct, 1 0 correct, correct, 1 0 wrong, then correct. Okay, then R implies P. Okay, R implies P. 0 to 0 correct, 1 to 0. See, like this it is going, R to P, right? 1 to 0 is false, 0 to 0 true, 1 to 0 again false, 0 to 1 true, 1 to 1 true, 0 to 1 true, 1 to 1 true. Now I will take P implies Q and Q implies R. I will just write here itself. 1 and 1 is 1, 1 and 1 is 1, here 0 is it, here 1, 0, 0, 0, 1. So I got my values for this P implies Q and Q implies R. Now I will multiply this, okay, 1 into 1, 1, 0, 0, 0, this is also 0, this is also 0, this is also 0, this is 1. Okay, you understood, right, what I did here? Now see here, this thing only first and last is 1, all are 0, first and last is 1, all are 0. So here we have proved that, or to say this is logically equivalent. Okay, let me see, move on to the second question. So they have said establish the validity of the following argument using rules of inference. Okay, using rules of inference I have to do this now. So here I have P and P implies Q and S or R and R implies negation Q. Okay, this whole thing implies S or T. First we will see, so they are saying this whole thing implies this. So first I have this, this. So this thing should be equivalent to this. Okay, let us try to solve how we can do that. Q, okay, that is F naught. Now see here, first thing here we have, you can see here, right, P implies P and P implies Q. From rules of inference, rule of inference, that modus ponens, I can simply write this whole thing as Q itself. And also I have here S or R. I can convert this S or R into negation S implies what to say, negation R. Okay, or else I can simply switch the this also here. Though we know this and from modus ponens we get this, we won't be considering this. So now what I will do, these two are there, right? I will see how I am writing S or R, and R implies negation Q. I can write it in a form, just a second. See, this S or R is there, right? I can write it in the form of negation S implies R. Okay, why? Because if you take, if you convert P implies, you see, we know that P implies Q in a, but negation P or Q. Okay, if I have to do like negation P implies Q, then it will become only P or Q. Why? Because I will have here double negation. You can see, right? Good, yeah, double negation, that will get over. So S or R, I can write it as negation S implies R. I showed you how we got here negation S implies R, and R implies negation Q. Okay, we have this rule of syllogism. If we have P implies Q, P implies Q and Q implies R, then we can simply write it as P implies R. Okay, so like that rule, if I apply here, you have to write here rule of then. So this thing I can reduce to negation S implies negation Q. Now this thing I can write as Q implies S. How? Because this is, see, contraposition. So if I do take contraposition of this, places will swap and negation will come further. So double negation, it will just cancel out. Only Q implies S is remaining. Now I will write this things as it is: P and P implies Q, P and P implies Q, P and P implies Q. Now again you can see here I can apply a rule of syllogism here. So I can write it as P and only P implies S should come. P implies S. Now I can apply the modus ponens. P and P implies S is nothing, S. Now you see here I have only S over here. Okay, S implies, so is my S is logically equivalent to this S or T? No, right? But one thing let me tell here, we had that first rule of inference is nothing but a rule of disjunctive application, which means P or Q is logically equivalent to only P. I can take ulta also, P is logically equivalent to P or Q also. So in the same way, what I am taking from this, I am writing S or T. Why? Because I am saying that S or T, I can say that S or T is logically equivalent to only S. So I can convert this S as S or T again back. So I am taking S or T. So now this is logically equivalent to my actual answer. Okay, this is how we solved that second question on the model paper. Now let us move on to the third question. It says for the universal, for all the new synthesis, let P of x, Q of x, R of x, and okay, denote the following statement. Okay, so this is quantifiers question. P of x is x greater than 0. Q of x is even. R of x is x is perfect square. S of x is x is divisible by 3. Then after x, what? T of x is divisible by 7. Okay, so now I have to write the following statements in symbolic form. First one, they have said at least one integer is even. See, since they have said at least, they have not said all integers are even. They have said at least one integer, means we have to write there exist x such that, now see, Q of x is even, right? So I will just write there exists x Q of x. Okay, this will be my answer for this first statement. Then let us move on to a second statement. Let me see here. Okay, so second statement, I will write this here. First one was there exists x such that Q of x. Now you look into question paper or write down the question paper questions. Now second question they have asked, there exists a positive integer that is even. There exists a positive integer that is even. I am just writing shortly. So there exists, again there exists x such that it is a positive integer and it is even. See, I know that Q of x is even, but first I have to write something here that should make it positive. So I know that x, P of x is x greater than 0. So I can simply write P of x and Q of x. How? Means P of x is greater than 0, right? X is greater than 0, which means all are positive. All of P of x is positive. So P of x is greater than 0 and it is even. Okay, so x is greater than 0 and x is even. That's what it means, right? Now from this statement you can say there exists a positive integer that is even. So we got understood, right? Let me just write it here. Second one, there exists x such that P of x and Q of x. Third question, at least one integer. Okay, third question, if x is even, then x is not divisible by 3. Okay, if x is even, then x is not divisible by 3. Now see here, if then, so I should have this in the form implies will be there. So now what they are saying, they have not said okay, if x is even, then x is not. So this means for all x, where is x, which is x even? Q of x. If Q of x is even, then it implies x is not divisible by 3. We have S of x as x is divisible by 3. So I simply write negation S of x. S of x is divisible by 3. If I take negation f of x, it is not divisible by 3. Okay. Then fourth question, no even integer is divisible by 7. Okay. No even integer is divisible by 7. So no even integer, we are saying. So if even integer, we know what is even integer. So see, for all x, no even integer. So for all x, we know that q of x is even integer. No even integer means negation q of x even integer is divisible by 7. Okay, and t of x. Okay, for all x, you can say that q of x and t of x for all x. Let me read the question again. We are saying no even integer is divisible by 7. Okay, correct, because no even integer, we don't have any even integer, right? Q is even integer, so I'll write negation q of negation q of just a second, no even integer. Okay, q of x even integer, which means even integer is not divisible by 7, right? Sorry, so it will come like this, huh? Sorry for that. We have to read these questions properly. Okay, so once again let me read the question in the model paper. No even integer is divisible by 7, so which means that even integers is not divisible by 7. So even integer and not divisible by 7. Okay, that's what it means. Okay, then last question, there exists even integer which is divisible by 3. So fifth one, there exists even integer q of x which is divisible by 3 and s of x, simply s of x I write. Okay, that's it. First part of this model paper is done. Then second question, define tautology. Prove that for any propositions p, q, r. Okay, first tautology is what? The tautology is a compound statement in which what we say the truth value is always 1. Okay, a compound proposition which is true for all possible truth values of its component is called tautology. I am dictating it, just write a compound proposition in which all the truth values are always true of its component, which is called tautology. Okay, then what they have asked me, same how I solved first day, I have to solve like that. So they have said that I have to prove that p implies q and q implies r, which whole implies p implies r, it is tautology. So now I have p q r, so I have to take like this, p q r 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. Done. Now first let me take p implies q, then let me take q implies r, then let me also take p implies r, all the terms one by one. Then I will take p implies q and q implies r, then I will take this whole thing implies p implies r. Okay, now p implies q, 0 to 0, that is 1, 0 to 0 1, 0 to 1 1, 0 to 1 is true, 1 to 0 false. Why? Because it is decreasing. 1 to 1 true true true. Q implies r, 0 to 0 1, 0 to 1 1, 1 to 0 is 0, 1 to 1 is 1, 0 to 0 sorry 1, 0 to 1 is 1, again 1 to 0 is 0, 1 to 1 is 1. Then p implies r, 0 to 0, see 0 to 0, 0 to 1 is also true, 0 to 0 is also true, 0 to 1 is also true, 1 to 0 it is decreasing, that is false, 1 to 1 is true, again 1 to 0 is decreasing, false, 1 to 1 is true. Okay, now p implies q, this thing and this thing I am multiplying, 1 to 1 is 1 1 to 1 is 1, 1 0 is 0, 1 1 is 1, 0 0 0 1, wherever 0 is there, 4 places 0 is there, just write off 0, remaining all places will be 1. Now this thing implies this, 1 implies 1 is 1, 1 implies 1 is 1. Okay, 0 implies 1 is also true, 1 implies 1 is 1, 0 to 0 is true, 0 to 1 is true, 0 to 0 is true, 1 to 1 is true. Okay. Now see here, P implies Q and Q implies R, whole implies P implies R, all the values I got true. You understood, right, how I got true? Like this you are taking, this implies like this, okay, like that values. If you don't know how to like solve this, I have explained all the concepts in that first lecture, okay, you can go and check this. Then prove the following using laws of logic, they have said. Let us prove that also. P implies Q implies R is logically equivalent to P and Q implies R. Okay, P and Q implies R. See now, this P implies Q is equals to negation P or Q. Okay, you remember this. So according to that, first I'll take. So I have, see here, I have P implies Q, right? Now I can take. Wait, let me see the questions once again. I have copied it properly. P implies Q implies R is logical into P and Q implies R. Okay, negation P or Q implies R. Okay, first thing this will happen. Then negation P as it is or as it is. Then I'll write Q implies R. I'll write as negation Q or R. Now using this since we know that, like this you write off since. Now here I can, using that associative law, I can group like this P or Q or negation P or negation Q, then or R. Now here from De Morgan's law we know that negation of P and Q is logically equivalent to negation of P and Q to negation P or negation Q. From De Morgan's law I can write this as negation of P and Q or R. Now see here, this thing is in the form of negation P or Q, so I can write it as P and Q implies R. Same thing I got, right? That's what it means. Now see here, what is this? Is P, whole thing is one term P. I have negation P or Q, negation P or, instead of R I have Q, right? So this is logically equivalent to P implies Q. Say again you write off since P implies Q is logically to negation P or Q over. Very simple, right? Let us see how much time I am taking to make this video. So the whole question paper I am explaining or also and that also. Okay, will I be able to complete in what to say 3 hours or what? Given direct proof, indirect proof, proof by contradiction for the following statement. If n is an odd integer, if n is odd integer, then n plus 9 is an even integer. So this direct proof, indirect proof and proof by contradiction. So 3 things are there in this. So direct proof, first see, we can see here in direct proof what it say, we assume that n is odd integer, we assume n is odd. Direct proof, in this what will happen, if n is odd, then n is equals to 2k plus 1. How I write this is nothing but, see, for any number, say any number k, for it to be even I will simply multiply it by 2. We know that 2 into any number is even. Since this number is even, if I add plus 1, the even plus 1 is odd number. You understood, right? So I will write n is equals to 2k plus 1 for some integer k. Then n plus 9 is equals to 2k plus, so here I am adding 9 on both the side, n plus 9 is equals to 2k plus 1 plus 9, 1 plus 9 is nothing but 10. Okay. Now 2k plus 10, which is equals to if I take 2 common, that is k plus 5 here. Okay, I took k common, n plus 9 is equals to 2 into k plus 5. Now see here, this is one number now, but it is a multiple of 2. Since this is k plus 5 is multiple of 2, I can say that n plus 9 is even. You understood, right? For any number to be even, it should be a multiple of 2. Now I got this k plus 5 as one term which is multiple of 2. So in my direct proof I can say that 2 into n plus 9 is even. Okay, first, but you have to write first, let us assume n is equals to n is an odd number, therefore n is equals to 2k plus 1, like that. From there just add 9 on both the side, then take 2 common, you can show that n plus 9 is what to say even number. Then indirect proof, we assume that in indirect proof, in direct proof we have to use 9 is odd. In indirect proof I'll assume n plus 9 is odd, which means n plus 9 is equals to 2 into so here 2k plus 1, right? The same thing we did here. Now what I will do, I will keep n here as it is. Now I have to, now I am assuming this is odd, I have to prove that this is also odd or even, like that. So I will keep n as it is, I will set 9 there. So 2k plus 1 minus 9, which is equals to 2k minus 8. Okay, now again n is equal, again I will take 2 common, that is nothing but k minus 4. Now I can say that it is a multiple of 2, n is even. Okay, this is my indirect proof. Now proof by contradiction, how I will do that? You understood, right? In direct proof I assume this is odd, in indirect proof I assume this is odd. In this, first what I will do, I will take is equals to 2k plus 1, I will add 9 on both the sides, then I will take 2 common. Here what I will do, I will take 9 plus n plus 9 is that odd number, I will send 9 there, and then again I will take 2 common, very simple, nothing else is there. In proof of contradiction we assume that the given this statement itself is false, that is we assume that n is odd and n plus 9 is odd. Since n plus 9 is odd, okay, if p what to say p, if n is odd, then n plus 9 is an even integer, is there, right? So what I am doing, I am assuming this is odd, but I am assuming this is also odd. Here they have said even, right? In the question, let me just see the question. In the question what they have said, n plus 9 is even integer. If n is odd integer, then n plus 9 is even integer. From direct proof I have showed that first we assumed n is odd, then I got n plus 9 is even integer. Then here I assumed n plus 9 is what to say odd integer, I got n is as even integer. Okay, so I can say that if n is odd, then if this is odd, this is even, then if it is even, then automatically this will become odd, like that. Now in proof of contradiction, what I am saying, I am considering this whole statement as false. See here, it's in the form, this is p, right, and this is q, right? P implies q. Okay, so what I am considering both as if I am considering this statement as false, so I am considering this as false, this as true itself. So 1 implies 0. See what I am going to, this is even they have given, but I am considering this as odd now. So the 1 implies 0 is false only, right? Okay, like that I am considering. Now see here, since n plus 1, now I am considering assumed n plus 9 is odd. Since n plus 9 is odd, then n plus 9 is equals to 2k plus 1, which is equals to, I will write same way, 2k plus 1 minus 9 is equals to 2 common k minus 4, like that I will write and keep off, which shows that n is even, which shows that n is even. Now what I can say, when I assumed n plus 9 as odd, I am getting this as even, which means my p is 0 I am getting. So from this statement, therefore this contradicts the assumption that n is odd, therefore I can say that hence the given statement is true, which means 0 implies 0 is true, right? Or even if I take this as even integer, I assumed it as odd, right? I assumed it as 0 means odd, but I am assuming here even. So 0 implies 1 is nothing but true itself, like that I am just doing. Just you are using indirect proof statement writing here, keep your mind like this. So p is true, but you are taking q is false, so this is a false statement. Now I will prove this from false statement, n is odd, I will prove that p is even. Here we had taken that p is odd, but we got to know that p is even. So 0 implies 0 is true from contradiction. You don't have to write so much. You can just say that from contradiction you can say that it is. So we have completed first module. So I took, oh my god, half an hour to complete the first module. Okay, let me go to the second module. Prove that 1 square, 1 square, 3 square, 5 square, so on, plus 2n minus 1 the whole square is equals to n into 2n plus 1 into 2n minus 1 whole divided by 3. Now first I have to assume mathematical induction, right? So first I will assume s of n is this. Okay, I will write like this, s of n is this. So I will take s of 1 now. What is s of 1? 2 into 1 is this, 2 minus 1 whole square is equals to 1 into 2 plus 1 into 2 minus 1 whole by 3. 2 minus 1 is nothing but 1, which is equal to 3 by 3, which is equals to 1. 2 minus 1 is 1 square, 1 square is equals to 1. So 1 is equals to 1. Therefore I can say that s of n is true for all n greater than equal to, for all n greater than equal to 1. Now I can, this is my basic step over, so I can write inductive step where I will say s of k is true where n is equals to k for all n for n is equals to k where k is greater than equal to 1, like this. I will say let us assume s of k is true for n is equals to k where k is greater than equal to 1. We need to prove that s of k plus 1. So now see here, s of k plus 1 is what? What is s of k now? 2k minus 1 the whole square. If I take s of k plus 1, then I will get 2k square should come, right? Here it will become 2k square. But in the right hand side I should have, see here, s of k means k into 2k plus 1 into 2k minus 1 whole by 3. What I have to get in the final answer? It should be k plus 1 into 2 into k plus 1, 2k plus 2. See, 2 into k plus 1 is there, right? 2 into k plus 2 into 1 is 2. So I will write 2k plus 2. I have plus 1, so that is nothing but 2k plus 3 into again same 2k. So it will be 2k plus 2 minus 1, which is nothing but 2k plus 1 whole divided by 3. So this I should have in my final answer. So now what I will do, in both the hand side I will add one term, which what I will add in both the hand side. I will simply add 2k plus 1 the whole square. Okay, s of k plus 1 is there, right? So now see here, you know that I have to get there. How to decide what you have to add? So here I have 2k minus 1 whole square. Now if I substitute k as k plus 1, so 2 into k plus 1 minus 1 whole square I have to take, which is nothing but 2k plus 2 minus 1, which is nothing but 2k plus 1 the whole square. I got this side. Now this only I will add on both the sides. So I will have s of k plus 1 such that 1 square plus 3 square plus so on 2k minus 1 the whole square plus 2k plus 1 the whole square is equals to, here k into 2k plus 1 into 2k minus 1 by 3 into plus 2k plus 1 the whole square. Okay, I will take like this 2k plus 1 the whole square. Okay, now what I will do, I will take common. What I will take common? I will take 2k plus 1 common. Okay, I will just erase this part. I will write it here again. Okay, now I have to take 2, I will take 2k plus 1 as common. So whatever I am adding here, right, mostly every time I will take that itself as common, along with this denominator. Okay, if I take this common, so see here I have here also one 2k plus 1. So what I will have in this place, 3 is also going, this and this I am taking out as common, here also I am taking that as common. So here it will be only remaining is k into 2k minus 1 plus, here 2k plus 1 I am taking common, but 2k plus 1 divided by 3 I am taking as common. So here I will write 3 into 2k plus 1. Since it was square, so one thing if I take 1 will remain. See why I am taking 3, writing 3 here, because I am taking 2k plus 1 by 3 as common. So if I multiply this inside now, you can see you will get k into 2k minus 1 into 2k plus 1 by 3, which is same as that previous sum, plus 3 into 2k plus 1 into 2k plus 1, this is nothing but 2k plus 1 the whole square. 3 by 3 will cancel out here. Okay. Now just open this bracket. So 2k square minus k plus 3 to the 6k plus 3. So this is nothing but minus k plus 6k is nothing but plus 5k. So now I have to simplify this. Just as you see, this 2 is here, so I will multiply here 2 3 the 6. So now by adding it should be 5, by multiplying it should be 6. So how can you do that? That is nothing but 2k square I add as it plus 2k plus 3k plus 3. Okay. Then I will take 2k common. What is remaining? K plus 1. I will take here 3 common. I will have k plus 1. Okay, this thing is still there as it is. Then what I will take? I will take k plus 1 first. I will write common terms. Then remaining is 2k plus 3. Okay. Now I simplified this whole thing into this. Let me just write this here. I don't have that a long space, so I am writing like this. Okay. So what I will get here? K plus 1 into 2k plus 3. Okay. Now if you see here, in the beginning I showed you, right, this is the actual term which I wanted actually. I will show you how. See, from this I will write k into 2k plus 1 into 2k minus 1 whole by 3. If I write it in the terms of k plus 1, so k plus 1 into k becomes k plus 1 into 2k plus 1, 2k plus 2 plus 1. Why? Because 2 into k plus 1 it is. So 2k plus 2. So 2k plus 2 plus 1, which is nothing but 2k plus 3 into 2 into k minus 1. So 2 into k plus 1 minus 1, which is nothing but 2k plus 2 minus 1. 2 minus 1 is plus 1 whole divided by 3. Now see, is it same or not? So I have 2k plus 1, yeah I have k plus 1, I have 2k plus 3, yeah I have, divided by 3 also it is there. Okay, order is same, but the final answer is same. Okay, I proved it by using mathematical induction that my given statement is true. Let us go for the next question, that is recurrence relation. Yeah, given a naught is equals to 1, a1 is equals to 2, a2 is equals to 3, and an is equals to an minus 1 plus an minus 2 plus an minus 3 for n greater than equals to 3. Prove that, so they have given this one and they are saying prove that an is less than 3 power n for all n greater than for all n belongs to positive integer z. So this is a given question, they are asking us to prove that. Okay, so I can take that they have said me to prove this, right? So I will take s of n as this. S of n is an less than equal to 3 to the power of n. Now since they have said n greater than equal to 3, so I will take s of 3 first, which means a3 is less than equal to 3 to the power of 3, that is okay, so this n greater than 3 was for this thing. For here n belongs to positive integer, right? So instead of 3, let me take start from 0, since a naught they have said, right? So a naught is equals to a naught is less than equal to 3 to the power of 0, which is nothing but 1. It is true, right? Then s1 I will take a1 less than equals to 3 to the power 1, that is 3. Do I have anyone true? Okay, so less than equals to 3, a1 is less than equal to 3, right? So a1 is 2, it is true, right? It is not equal to 3, it is less than equal to 3. So therefore a1 is equals to 2 will get, therefore a naught is equals to 1 I will write. Then I will take s of 2 here. If I take a2 is less than equal to 3 square is less than equal to 9. Okay, so I can take that therefore a2 is equals to 3. I can take from the given statement, it is less than 9, right? So I will take like this. Then I will assume this all this 3 terms is true. Okay, so if it is true, so I will say that s of n is true for all n belongs to this positive integer, like that. Then I will say like how mathematical induction is there. I will take s of k is also true for all k greater than equal to 2. I will take. Why am I taking k greater than equal to 2 is because the last time I took k, see, for s of 2 I am getting less than equal to 9. So all the terms here I had less than equal to 3, I had less than equals to 1, and here I had less than equals to 9. So for if I take 2, so I will take for all 2 k greater than equal to 2. Okay, so that if k is greater than equal to 2, so I will have always less than equals to 9 more than, so it will be true itself for all s of n. Okay, now what I will do, I will take s of k plus 1. Okay, s of k, what is s of k? S of k is nothing but this a of k less than equal to 3 power k. So I have to prove that s of k plus 1 such that a of k plus 1 is less than 3 of k plus 1. Okay, according to the question I can write like this. Then what I will do, first I will only consider a of k plus 1 is equals to a of k plus 1 is equals to, see here this equation I have had a of n is equals to a of n minus 1, n minus 2, n minus 3. So I have a of k plus 1. I will take a of, this is one term, right, k plus 1, instead of n I have k plus 1 minus 1 according to this, plus a of k plus 1 minus 2 plus a of k plus 1 minus 3. K plus 1 minus 1 is nothing but only k. I have only k here. Then k plus 1 minus 2, plus 1 minus 2 is minus 1, k minus 1. Then a of k plus 1 minus 3 is minus 2. So here I can write a of k minus 2. Now with the help of this equation I can derive what is a of k, what is a of k minus 1, and what is a of k minus 2. If it is a of k, then it is equals to 3 power k. Here same way, plus 3 power k minus 1 plus 3 power k minus 2. So I can say that s a of which is less than equal to a of k, a of 3k 3 power k. How I am converting this as 3 power k according to this equation. So s of k is right, or else let me say a of k is less than equal to 3 power k. So this thing a of k plus 1 is less than equal to, I am taking a of k means 3 power k less than equals to 3 power k, like that I am just taking and writing. Now then what I will do, 3 power k, 3 power k minus 1 plus 3 power k minus 2. Now this is less than equal to, see here k is there, k minus 1 is there, and here k minus 2 is there. If I take I can simply write it as 3 power k plus, again this is also I can write it as 3 power k itself, plus this also I will write as 3 power k. See why I am writing this 3 power k, k minus 1 is becoming k itself. Why? Because see I have here less than equal to this symbol, right? So here I have less than equal to symbol, so that I have to write it in such a way that, see, this is k, k minus 1 is obviously less than k, right, and k minus 2 is obviously less than k. Okay, that's why I am considering this k minus 1 as k itself, k minus 2 as also k. Then what I am doing here, I will take 3 power k common, so we will have 1 plus 1 plus 1 is nothing but 3 power k into 3. So bases are same, I will just add the power 3 power k plus 1. So what I had to prove, I have proved it using this relation. Just remember, you can whatever you get at the end, you got like this, right? You got like this. You have to make changes in such a way that you have to get your answer. You can do that. Why? Because it is less than equal to thing, right? So I can take anything over here. So you can simply take 3 power k, all as 3 power k, then 3 power k take as common, and then you will just write it. Then let us move on to the next question. So 3c, they have said find the number of way of arrangement of letters of the word Tallahassee which has no adjacents a. So first I have to consider T A L L A H A S S E. So T is one time, A how many times? 1 times, 2 times, 3 times. Okay, 3 times. L 1 time, 2 time, only 2 times is L. H is only 1 time. S is 2 times, E is 1 time. Correct? Am I right? So I can write first A is 3 times, then L and S as 2 times, then T H E as 1 time. How many letters are totally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in how many ways I can arrange this is nothing but 11 factorial divided by 3 factorial into 2 factorial. I have to just multiply this into 2 factorial into 1 factorial cube. Okay. How I got this nothing but this? See, first how many letters are there, that factorial divided by first how many times it is repeating, write off that factorial into this factorial into this factorial, same take all factors into like that I have to do, which is equals to 11 factorial divided by 3 factorial is what? 6 into 2 into 2. Okay, so I'll have 1, 2, 3, 4, 5, 6, like that. It's just 2 of 11 factorial divided by 6 to the 12 to the 24. 11 factorial divided by 24. You will get some what to say value. That will be your number of ways you can arrange this. Okay. So I can simply say here 24 it is equals to I'll write the direct answer. If you calculate, you will get the same thing. Okay, 600. I can do here. If you can see, I don't think you can see 11. I can take factorial here. Shift this. So 11 factorial divided by 24. Okay, 3 factorial into 2 factorial into 2 factorial. Let me see this ones again. T A L L A H A S S. Okay, here S S E E is there. Sorry. So E is also 2 times. So here I'll have another 2 factorial, another 1 factorial into 1 factorial. Okay, wait, so here it will be like 3 factorial is 6 into 2 into 2 into 2, 2 to the 4, 4 to the 8, 8 6 is 48. Okay, so if I do see here 11 factorial divided by 48, so I am getting 831,600. I can show. I don't know if you can see or not. You can see, right? Okay, that's it. So this is the number of way I can write 831,600. But what they have asked in question, we should not have find the ways of arrangement the letter of the word I say which have no adjacent A. So they are saying all these letters should not have adjacent A. Means what? Before any letter A should not come, after that letter A should not come. So what I can do for this? I'll simply what I'll do, I'll remove A itself. Okay, adjacent A should not be there, so I'll remove A now. So now see here, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial divided by 1 factorial into 2 factorial into 1 factorial into 2 factorial into 2 factorial. This is your answer, which is nothing but 8 factorial divided by 2 to the 4, 4 to the 8. So it will be nothing but 8 factorial divided by 8, which is 5040. Okay, you will get that as your answer. So in each of this arrangement there are okay, like that you can say simply write 5040. That's it. Okay, that's it. You can in each of this arrangement, the how many letters we will not have adjacent A is this, write and leave off. Let us go to second option. Determine the coefficient of x, y, z square in the expansion of 2x minus y minus z to the power of 4. Now I can say that from the given question, x1 is equals to 2x, x2 is equals to minus y, x3 is equals to minus z to the power of 4. Okay, in the minus z. This is my n is equals to 4, and from this given equation I can say that n1 is equals to 1, n2 is equals to 1, and n3 is equals to 2. Okay, this power is n1, this power is n2, this power is n3. So n is equals to n1 plus n2 plus n3. It should be always 4 is equals to 1 plus 2, 4 only, right? Now I have this formula for this. What is it? This comes under, I guess, multinomial and that thing. So what is the formula for this? Is nothing but like this. It is n1 into n3 into, so x1 to the power of n1 comma into x2 to the power of n2 into x3 to the power of n3. Okay, this is the expansion for x plus x2 plus x3 x1 is equals to expansion of this is equals to, this is the formula. Now let me just substitute. In place of n I have 4, in place of n1 I have 1, in place of n2 I have 1, in place of n3 I have 2, and this I can write as, see, 2x to the power of n1. Okay, 2x to the power of 1 into minus y to the power of 1 into minus z to the power of n3, that is 2. What I will get? See here, 2x minus 2x y z square. Okay, let me just write here minus 2x y z square. Now see here, I wanted coefficient of this. So what I will do? I will keep this as it is. I will only calculate this. So 4 1 1 2. This is nothing but 4 factorial divided by 1 factorial into 1 factorial into 2 factorial into minus 2. So you have to calculate this. So 4 factorial is nothing but 24. Okay, 24 divided by 2, there is nothing but 12. 12 into minus 2 is minus 24. So minus 24 is your answer. Coefficient minus 24 is the coefficient of x, y, z square. From this you can say that minus 24 is your coefficient of this expansion. Okay, very simple. It was the easiest sum. Then in how many ways one can distribute 8 identical marbles into 4 distinct containers? This is also very easy question. I think this is this combination with repetitions. Okay, see, when they say 8 identical marbles, means all 8 marbles are same, that is your R is equals to 8. Then 4 distinct containers means n is equals to 4, such so that no container is empty. Okay, so first I have to find for no container is empty. So first the formula is given by C of n comma r is equals to, sorry, here not n comma r, C of n plus r minus 1 comma r is equals to C of n comma r. So in place of n I have 4 plus 8 minus 1 comma 8. Correct. Then this is the formula, right, which is equals to 4 plus 7 or is it let me just cross check one second with the formula. Okay, so I think the formula was right itself. Okay, remember that C of n plus r minus 1 comma r is equals to C of n comma r. So here in the first question they have given no container is empty. So 4 containers are there. Okay, n is equals to 4. First what I will do, in each container I will put this one ball. So remaining r is equals to 4 now, and n is also 4 now. So now for this I have to remove the get that this one. So now my r is 4 and n is 4. So I will put C of n plus r minus 1 comma r, which is nothing but see 4 plus 4 minus 1 comma 4. 4 plus 3 is 7 comma 4. C of 7 comma 4, which is nothing but 7C4. So the answer for your first question is that is no container is empty is 7C4. Okay, you have to in calculator I can do, see in front of you I will do 7 shift division 4, which is nothing but 35. So the first answer will be 35. Okay, let us move on to the second question. In second question what I have said, let me see the question. The fourth container has odd number of marbles in it. Okay, this fourth container will have odd numbers of marbles. Either it can have 1, it can have 3, it can have 5, it can have 7. Okay, so it will have odd number of marbles. It will have either what to say, it will have either 1. If I take, okay, so first I will take, suppose we put only one ball in this, odd numbers, right? So in the remaining how much I can fill? Remaining 7 I can fill here as it is. Okay, this, okay, I have to take 4 cases one by one. If I am putting 1 here, so r will become my 7 now, and n is equals to 3 now. Okay, how n is 3? Because I cannot do any changes in this now, only in this 3 I have to do. So n is 3, n is equals to 3, this 7. Now I have to put the same formula, C of n plus r minus 1 comma r, this is 3 plus 7 minus 1 comma 7, that is 7 minus 3 plus 6 is 9 comma 7, C of 9 comma 7. First I will get like this. Now I will take here 3, I will put here. Now I will consider 3 now, 1 is over. If I am taking 3 marbles, so odd marbles, right? So remaining how much? 8 minus 3. What is 8 minus 3? That is 5. So I can place 5 here and is still 3. Okay, I will substitute this here now. So first I got for 1, okay, I got 9 comma 7, C of 9 comma 7. Now let me just remove this. So r is now 5. 5 minus 1 is 4. So 3 plus 4 is 7 comma 5. Then I have C of 7 comma 5. Okay, you understood that how I got 7 comma 5. Then I insert 5 marbles into this container. No changes can be done now. If I insert 5 marbles, then r will be 8 minus 5, that is my, now r is equals to 3. So now 3 plus 3 minus 1 comma 3, that will become 3 plus 3 minus 1, 2. 3 plus 2 is nothing but 5 comma 3. Then I have C 5 comma 3. Then I will insert 7 here. So only r will be 1 now. Only 1 I can insert anything. So here r is 1. This is 1. So this will become 3 plus 1 minus 1 is nothing but 3 itself, and here C of 3 comma 1. Okay, you understood, right? I got. So when I am inserting 1 marble in the fourth container, 3 marble, 5 marble, 7 marble. So what will be my final answer? So C of 9 comma 7 is nothing but 9C7 plus 7C5 plus 5C3 plus 3C1. You have to add all these answers now. Okay, so if you add, if I can do this in front of you, 9C7 is equals to 36. Then 7C5, see, you can see, right? 7C5, 7C5 is equals to 21 plus 5C3, C5C3 is 10 plus 3C1 is I guess 3 itself. Yeah, 3C1 is 3. So now I will add 36 plus 21 plus 10 plus 3 gives me 70. So this is my answer for second question. Okay, let us move on to the next question without wasting any time. See, this is also one easy question. Same way, same thing. This is only combination, I guess. In how many positive integers n we can we form using the digits? So they have given these many digits: 3, 4, 4, 5, 5, 6, 7. If you want to exceed n, 5 million or 50 lakh also you can say. Okay, so now I have, see, 1, 2, 3, 4, 5, 6, 7. So how many digits are there? 1, 2, 3. See, 7 digits are there. 7 digits are there, and they are saying using these digits, I have to find that how to say how many ways I can arrange this thing in such a way. This is permutation only, in such a way that it should exceed 5 million. So for it to exceed 5 million, my first digit should be either 5, or it should be either 6, or it should be either 7. Are you understanding, right? So now what I will take, permutation I will take now. Same permutation is what how for Hasse we did, like that itself. Now if I am considering, so suppose I will say that let these digits be these places now. Okay, it should be either 5 or 6 or 7. This is x1, x2, x3, x4, x5, x6, x7. So let you have to say that each digit to be like this x1 x2. So for the sum to exceed 5 million, for that x1 should be either 5, 6 or 7. Now understood. Then what I will do, first I will consider x1 is equals to 5. If I am considering x1 is equals to 5, then what will be my permutation? I am taking x1 as 5. Okay, so I will write the remaining letters 1, 2, 3, 4, 5, 6, that is 6 factorial divided by 3 has repeated 1 time, so only 1 factorial, into 4 has repeated 2 times, so 2 factorial, into 5 has only 5 is only 1 time now, because this 5 I have taken out. Remaining, see here, 1, 2, 3, 4, 5, 6, 7, right? So 5 is taken. Remaining 6 places. Permutation. In how many ways I can arrange these 6 places using the remaining 6 digits? That's what I am doing here. 5 is only 1 time, so 1 factorial, into 6 is 1 time, 1 factorial, again 1 factorial. Okay, this is my answer. So I have to just calculate 6 factorial divided by, see, 6 factorial divided by only 1 2 factorial is there, right? So only 2 I will write, that is my 360. Okay, if x1 is equals to 5, my answer is 360. Now I will take x1 is equals to 6. Okay, instead of 5, now I am taking it as 6. So see here, 1, 2, 3, 4, 5, 6, 7. Now I am taking 6 here. So remaining this place I can fill with the remaining digits, that is 3, 4, 4, 5, 5, 7. So it is again how same 6 factorial again. How many numbers are remaining? 1, 2, 3, 4, 5, 6 into 3. Okay, first see 4 has come 2 times, so 2 factorial, into 5 has come 2 times, so 2 factorial, into remaining 3 and 7 has come only 1 time, so 1 factorial into 1 factorial. So simply what I will do, same question, numerator 6 factorial itself, only what I will do, in denominator I will write it as 4. Why I am writing 4? Because 2 factorial into 2 factorial is 4. So my answer is 180 now. When x1 is equals to 5, then my answer is 360. Okay, for this my answer is 180 now. Okay, so when x1 is equals to 6, my answer is 180. Similarly, I will consider now 7. When x1 is equals to 7. Okay, so now instead of 6, I will go to 7. See, if you can see here, if x1 is 7, the remaining 6 places can be filled. So see, same, it is same itself. 6 factorial into divided by, see, 4 is 2 times, 5 is 2 times, 3 is 1 time, 6 is 1 time, 4 2 times, 5 2 times, 6 1 times, 3 1 times. So this answer also will give me same. Okay, now I can see that if I got these three values, right, when x1 is equals to 5, when x1 is equals to 6, when x1 is equals to 7, I just have to add these three numbers, 360 plus 180 plus 180. So then for 360 plus 360, that is your answer is 720 is your answer for this question. I have completed module 2. What is the time? Oh, it is 1 hour 5 minutes. Okay, so 2 modules I completed by the 2 are options. Now let me move on to this module 3. Okay, so I'll first upload this first part, module 1 and 2, then I will make module 3 in different set. Or let me do half now at least. So in question they get let f be a function r to r, it seems defined by f of x is equals to 3x minus 5 3x minus 5 if x is greater than 0. They have said else 1 minus 3x if x is less than equal to 0. Okay, now they have asked us to find f inverse of 0, f inverse of 1, f inverse minus 1, 3, 6, minus 6 comma 5 and minus 5 comma 5. So let me find f inverse of 0. Okay, f inverse 0 means nothing but I have to write find the pre-images of 0. Nothing but f inverse of 0 is nothing but okay, f inverse of x, and here which is nothing but x is equals to 0, right? So I have to substitute this. 1 second. F of 0, f inverse of 0 is nothing but f inverse of 0. Okay, so I have to substitute this 3x minus 5 in place of x I will write 0. So 3 into 0. Okay, so 0 minus 5 is minus 5. Is my minus 5 greater than 0? No. Okay, then I will take f inverse of 0 for this. Okay, 1 minus 3x, so 1 minus 0. Is my 1 less than how to say equal to 0? No, right? So see here in the question they have given 3x minus 5 if x is greater than 0, 1 minus 3x if x is less than equal to 0. First I will take for f inverse 0. If my f inverse is 0, oh okay, 3 into 0 minus 5, that is 0 minus 5, that is minus 5. And then for this 1 minus 3 into 0, that is 1, like that I will take. Okay, so here I was not supposed to take both actions. See here f inverse 0, right? So we the first value is 0, so 0 falls under this category. So I have to take this equation 1 minus 3x. So f of 0, f inverse of 0 is nothing but f of x is equals to 0. And now what I have in the place of x, that is 0. F of 0 is nothing but 1 minus 3 into 0, which is nothing but 1, which is equals to, okay, that's it. So this is my answer for f of 0. Okay, similarly f inverse of second sub question which they have asked is f inverse of 1. F inverse of 1, how will take the value 1, it is greater than 0, so I will substitute f of 1 in this 3x minus 5, that is 3 into 1 minus 5, which is equal to 3 minus 5, that is 2, minus 2. F inverse of 1 is minus 2. First I got 1, then minus 2. F inverse of 0, f inverse of 1. Similarly, f inverse of minus 1. Minus 1 is less than 0, so 1 minus 3 of minus 1, this is 1 minus of minus 3, which is 1 plus 3 is equals to 4. So f inverse of minus 1 is 4. Okay, f inverse of minus 3 now. Okay, f of minus 3 means this equation 1 minus 3, instead of x minus 3 I have, so minus 3 into minus 3 is plus 9, so 1 plus 9 is equals to 10. So this is 10. Simple, right? Then f inverse of 6 minus 6, no, plus 6. Okay, f inverse of 6. Okay, what will have? 6, 1 into 1 minus 3 into 6, 3 6 is 18, 1 minus 18 minus 17. Okay, then they have asked f inverse of minus 6 comma 5. This thing how you will do? So see, they have asked minus 6 comma 5. So first I will take this equation, for this equation minus 6 comma 5, right? So first what I will do, I will go for minus 6 comma 5. I will consider this equation first, minus 1 minus 3x, then simultaneously I will consider this equation 3x minus 5. Okay, first I will consider like this, then I will solve. What I will get, 1 minus 3x, 1 minus 3 into minus 6, 3 into 5 minus 5. Since they have asked like minus 6 comma 5, right? Minus 6 comma 5, we have two values here. For two values, what we will take? We will consider both the equations. I will use both the values for this 3x minus 5 for x greater than 0, and here 1 minus 3x for x less than equal to 0. So see here, I have 3x minus 5. Okay, it should be less than minus 6. This should be less than equal to 5. Same way, 1 minus 3x, this should be less than equal to minus 6. This should be less than equal to 5. Okay, now I have to solve. I have to I have to do some changes such a way that only x remains. So here I have 3x minus 5. So what I will do, I will add 5 on both the sides. So minus 6 plus 5 is minus 1, less than equals to 3x. Minus 5 plus 5 will go up. Okay, then here less than equal to 5 plus 5 will come 10. Add 5 all places. Then I will divide by 3. So that then divide by 3. So I will have minus 1 by 3 less than equals to x less than equals to 10 by 3. Same I will do here. 1 minus 3x is there. So I will subtract 1 here. Minus 1. So minus 6 minus 1 is minus 7 less than equals to 1 minus 1 is only minus 3x is there, less than equals to, here I will have 4. Then divide by minus 3. Minus 7 by minus 3 is only 7, plus 7 by 3 less than equals to 3x less than equals to minus 4 by 3. Okay, so this I can again shift the places, right? So I can send minus 4x by 3 here, and what to say, 7 by 3 I will put here. Okay, so now I got this and then I got this. So what I will do, f inverse of minus 6 comma 5, I will take such that I will say this or this. So what I will take, I will take lower limit from this, since this is x less than 0, right? It is x less than 0, so I will take the less than 0 place, less than x value here. Okay, and here this is x greater than 0, so I will take greater value here. So at the end what I will do, I will write my required answer is minus 4 comma 3 comma 10 by 3. Okay, this is my answer. Okay, if okay, for f inverse of minus 6 comma 3, I got minus 4 by 3 comma 10 by 3. Suppose if they ask 5 comma 5 also, they have already asked minus 5 comma 5. How I will do that? First I will write 3x minus 5, and here I will write 1 minus 3x. So they have said minus 5 comma 5. So minus 5 less than equal to this, less than equal to 5. Minus 5 less than equal to this, less than equals to 5. I have to first write like this. Okay, then I have to add 5 here now. Okay, so if I add 5 here plus 5, same I will do. 0 less than equals to 3x less than equals to 10, then divide by 3. 0 less than equals to x less than equals to 10 by 3. Similarly, here I have to minus 1, so minus 6 less than equals to 3x less than equals to 4, then divide by minus 3. So minus 3 divided by minus 3, minus 6 divided by minus 3 is plus 2 less than equals to minus less than equals to x less than equals to minus 4 by 3. I will rearrange it. So I will write minus 4 by 3 here, then I will write 2 here. So then from this what you can do, I will take the lower limit from less than x less than 0 equals to 0, I will take here. From x greater than 0, I will take this higher value, I will take. So even for minus 5 comma 5, I get the same answer. Okay, so let us see for next question. State pigeonhole principle and prove that in any set of 29 persons, at least 5 persons have been born on the same day. Okay, on the same day of the week. So pigeonhole principle I will say orally. So pigeonhole principle. Okay, treating okay, first pigeonhole principle is nothing but suppose there are so pigeonhole principle states that if there are m number of holes and n number of pigeons, then what to say, some pigeons, okay, they will occupy n plus 1 pigeon will occupy same okay, for example 4 holes are there and 5 pigeons are there, so each place 1 pigeon, so one hole will occupy more than 1 pigeons, okay, more than 1 pigeon it will occupy, that you have to write in a theoretical manner, okay. And then we also have that formula also for that, p of like that you will have. So I will just for a moment I will just state out it properly for you. Okay, so now I will read out that properly. So if there are m pigeons, okay, if n pigeons are there and n pigeonholes are there, and m is greater than n, means what, pigeons are more than the number of pigeonholes, then 2 or two or more pigeon will occupy the same pigeonhole, okay, like this you can say. Now they have said, okay, even we have generalized the principle for this. First you have to state this, after this you have to write the generalizing principle. So you have to say, if m pigeons occupy n pigeonhole and m is greater than n, then at least one pigeon must contain p plus 1 or more pigeons in it. At least one pigeonhole must contain p plus 1 or more pigeons in it, where okay, where p is equals to m minus 1 divided by n. M is number of pigeons, then n is number of holes. So how many pigeons, okay, we have to calculate this p. P is nothing but how many persons will have that holes will be occupied by same number of pigeon, okay, how many holes, how many pigeons will occupy same hole, that formula we are writing. Okay, now let us move on to the question. We wrote the definition of principal home. Now I will keep this formula as it is. So in place of m, what do I have? So see here, 29 persons, at least 5 persons have born on the same day. 29 persons are there, at least 5 persons are born on the same day of the week. Week equals to 7. So my n is 7 and my m is 29. Okay, m is 29. Always remember n is 7, right? So m should be greater than n, right? So that's why you can take greater number as m value, lesser number as n value, which is equals to 29 minus 1 by 7, which is 28 by 7. 1s are 4s are, therefore p is equals to 4. So final answer is 4 persons are born on the same day of the week. At least 5 persons have been born. Okay, so p plus 1, right? according to question, the answer what to say, plus 1 should come here. I forgot to write here plus 1. Okay, in the formula this like this, it will be like this, plus 1 also will come. Okay, so here plus 1 is, so therefore 29 minus 1 by 7 plus 1, that is 28 by 7 plus 1 is equals to 4 plus 1 is equals to 5 pigeons. 5 persons will have a birthday, same birthday on the same day. Then they have also said like this, one more question we have, that is 5c. They have given let A is equals to set of 1 comma 2 comma 3 comma 4 comma 6. 5 is not there, 6. It is an R, they have said one R relation such that on A itself, R is relation on A cross A itself, such that A are it defined by A relates B if and only if A is multiple of B, which means if I have 4 here, 2 should be okay, let me take 2 here. 2 if I have 6 here, then 2 should be multiple of 6. If I have A relates B, A should 2, okay, A is multiple of B, so it will be like this, right? A is multiple of B, yeah, sorry, so that's what 6 is multiple of 2, 3, 1, then 4 is multiple of, see, if I will take like this from here, 6 is multiple of 3, 2, 1, then 4 is multiple of 2, 1, 4 itself 2 and 1, then next one 3 is multiple of only 1 will come, then 2 is multiple of 1, then 1 is multiple of, so these are my possible pairs. So I will take like this now, from the beginning I will start. See, I said 1 is multiple of 1 itself, 2 is multiple of 2 and 1 itself, 3 is multiple of 3 and 1, 4 is multiple of 4, 2, 1, 6 is multiple of 6, 2, 3, 1. So what will be my R relation? 1 comma 1 I will write first, then 2 comma 1, 2 comma 2, then 3 comma 3, 3 comma 1, okay, then 4 comma 4, 4 comma 2, 4 comma 1, then 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 6. Okay, so these are the possible what to say, elements or ordered pairs in my relation. From the given question I have removed this. So now what they have said, okay, represent the relation R as a matrix. Draw the diagraph and relation R now. Okay, now I have to draw this matrix. I have to draw its relation I have drawn here. I have to draw now matrix for this and diagram for this. Let me first draw matrix. Matrix is A cross A, so here 1, 2, 3, 4, 6, 1, 2, 3, 4, 6. So 1 comma 1 I have 1, 2 comma 1, 2 comma 1 I have 1, 2 comma 2 I have 1, 3 comma 3 I have 1, 3 comma 1 I have 1, 4 comma 4 I have 1, 4 comma 2 I have 1, 4 comma 1 I have 1, 6 comma 1 is 1, 6 comma 2 is 1, 6 comma 3 is 1, then 6 comma 6 is 1. So remaining places are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So now this is my matrix. How I will do diagraph? 6 are there, right? See here, 1, 2, 3, 4, 5, 6, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So 1 has a self loop, then 2 to 1, 2 to 1, then 2 to 2 itself, so 1 self loop, then 3 to 3, 1 self loop, then 3 to 1, then 4 to 4, 1 self loop, then 4 to 2 I have, then 4 to 1 also I have, then 6 to 1 I have. 5 is not there, right? Why did I do like that? Okay, wait, my bad. 1, 2, 3, 4 and 6. Say 4 to 4, 1 self loop was there, 4 to 2 I had, 4 to 1 I had, then 6 to 1, 6 to 2, 6 to 3, 6 to 6 itself. Okay, did I do everything? 4 to 4, 4 to 1, yeah, that's it. Now you can see here 1 has 1, 2, 3, 5 arrow marks towards itself. So in degree, okay, 1, 2, 3, 4, 6. Okay, for this I will write in degree and out degree. This is in degree, this is out degree. So in degree of 1, from 1 how many nodes are coming inside? That is only 5 arrows are coming. How many are going out? Only one is going out, that out degree. Okay, then from 2 how many nodes are coming? 1 arrow, 2 arrow, 3 arrow are coming inside. So 3 in degree. How many out degree? 1 arrow is going, here 1 arrow is going, that is 2. Then from 4 how many are coming inside? Only 1, that is itself. For 3, wait, for 3 how many coming inside? 1 from 6, 1 from itself, so that is 2. How many are going out? 1 is going to 3 itself, 1 is going to 1, so that is also 2. For 4 only 1 is coming inside in degree, that is its self. How many going out? 1, 2, for itself 3, 3 is going out. For 6 how many is going out? 1, 2, 3, 4 is going out. How many in? Only 1 in. Okay, then you have to draw like this and see, very simple question, done. Okay, let me also do the R part of this third module. If a function f, okay, they have given a function f such that a is to b, g is a function such that b to c, then h is a function such that c to d. Now, okay, one second, I will go to that place in the question paper. Okay. Okay, now what is said? Okay, what is the question? They have said functions, then prove that, I have to prove that h composition g composition f is equals to h composition g whole composition f. Okay, so now here what I have to do? First you have to write, since function a is to b, then this function is from b to c, then since this function is from c is to d. Okay, so we have both h of g of f and h of g of h composition g of function as are from a to c. So I can say that this and this is from a to d, totally it is from a to d. Okay, simply I will write like this. So now what I will do? First I will start for any random integer x belongs to a. Okay, since it is from a to d, right, so it should belong to a. So that what I will do? H composition g composition f, I will multiply this with x. Okay, if I multiply from that properties, we can say that this is equivalent to h composition, okay, g composition f of x. Okay, this will become h compo. Okay, first I will take this, I am taking, right, h composition g composition f into x. So first this will happen. So wait, this will be g of x into x. It was like this, then it becomes like this. Then what? How this will convert? So this will become h composition g into f of x. Okay. So what I will say? Now I will say f of x is equals to y. So this thing will convert into h composition g of y. Okay. Then what I will say? I will say let g of y is equals to z. So here I have h composition g of I is nothing but, okay, let me write it neatly, properly from the beginning. Okay, h composition g composition f into x I am taking. This is equivalent to h composition g into f of x. I am considering f of x as, what to say, okay, f of x as y. This will become h composition g of y. Then I am considering g of y as h composition, okay, g of H composition y is nothing but H into G of y. Okay, then I am considering this H of z. Okay, this is one part. Okay, how I am considering, see, g of x into this is one property, this comes under functions part, that property it is. Okay, then what I will do, now I have another part as H composition G composition F whole into x it is, right. Okay, now this how this will change. So this I will bring it inside H composition G into composition F into x. So is what F like this into x, x is like this. So this I can write as into f of x. Okay. Now what I am doing? I am considering again same f of x as y, H composition G into y. This thing can be written as H into G of y. Now G of y I will write this as H of z. Now see here, this thing is equals to this. Therefore, I can say that H composition G composition F is equals to H composition of G whole composition of F. That's it is there for this question. Okay. Now let me move on to another part that they have said. Show that if n plus num numbers are chosen from 1 to 2n, then at least one pair adds to 2n plus 1. Okay. This is very simple question they have given here. So now see here, these are okay. So A1 is my first set I have. Okay, n plus 1 is a okay. Let me read the question once again. N plus 1 is a number chosen from 1 to 2n. Okay, at least one. Now what I have to say? I have to show that, prove that at least one pair will add to, or to say this 2n plus 1. So I can take my suppose I will take consider one set is equals to A1 such that I have to get this, right. So 1 to 2n I will consider first term and last term 1 okay. I just saw in the phone that it was showing battery saver, that option. I think a part of that thing, my audio was not visible, I guess. There is no problem in your phone. Actually there was a pop-up window in my phone, so that part recording hasn't, but audio has not recorded, I guess. Anyways, what I have explained, I don't think audio is recorded. If by chance if my audio is missed, let me repeat it again. That composition part, how I am taking, considering that see H composition G composition F into x of z, right. How this I am writing as into f of x, that is one property in functions. Okay, if you don't have to worry, they won't ask so much, just remember that and write. In this what the question is, suppose okay, let me read the question once again if by chance it has not. So show that okay, n plus 1 numbers are chosen from 1 to 2n, okay, such that if there should be a pair from this number pair, such that it should be added, that sum of that pair should add to 2n plus 1. So what I will do first, my set 1, what I will do first, I will take the first element and then the last element 1 comma 2n. Okay, then I will take A2 is equals to 2 comma 2n minus 1, second number, last second number. Then A3 is equals to like that, what to say, 3 comma 2n minus 2, so on up to I will go an is equals to n comma 2n minus n plus 1. Okay, so here see this will go up to n, this is coming from 2n, right. See, it is like 1 to n, then n plus 1 to 2n. Okay, it is like this. So here it will be up to n. So here I will take 2n minus n plus 1. Okay, so you have to take like that, this will be like this in the bracket. So what they have said, if we take sum, it should be in a way such that the product should be 2n plus 1. Okay, if I add this 2 now, n comma n plus 1. So here n, so here 2n minus n minus n, 2n minus n is just n, then I will remove this plus 1 plus 1. Okay, so here it will be only n plus 1. Sorry, yeah, right, first term, last term, so on. If I go this this last term, this first term will remain. So now see here, if I add these two terms, it will give me 2n plus 1. If I add this thing, 2n minus 1 plus 2 is nothing but 2n minus 1 plus 2. Minus 1 plus 2 is what? Plus 1. So 2n plus 1. Same way, 2n minus 2 plus 3 is plus 1. So here n plus 1, that is 2n plus 1. So like this I can say there are these are the sets containing two numbers from 1 to 2n whose sum is 2 1. Since every number from 1 to 2n belongs to one of the above sets. See, every number from 1 to 2n belongs to one of the above set. Therefore, I can say that each of the n plus 1 numbers chosen must belong from the from one of the sets. Okay, like that, system theory, right? Since there are only n sets, two of the n plus 1 chosen numbers have to belong to the same set. Okay, so it has to belong to the same set. Like that, just write theory and just say off that. See, I have taken at least one they have said, right? At least one or two something they have said in the question. So at least two numbers add up to, okay, at least one pair add up to 2n plus 1. So here more than one pair have showed that add up to 2n plus 1. Like that you can prove and conclude. Then you have another question: draw the Hasse diagram representing the positive divisor of 72. Okay, 72, positive divisor of 72. Now I will remove the questions. Okay, which and all number divide 72. Okay, so my 1 divides 72, 1 divides every number, then 2, 72 is divided by 2, that is 2 into 36. Okay, let me just write like this: 1 comma 72. Okay, then I have to take two numbers. If I multiply, I will get 72. Then if I take 2 here, 2 into what number will give me 72 is 36. Is 3 divisible? Yeah. 3 into 24 times gives me 72. Then 4, yeah, it is also visible. 4 into 18 times. 5, no, 5 is not visible. Divisor 6 I can take. 6 into 12 times. 12 6 is 72. Then I can take 8 into 9 times. Okay, I'll make this like this. Then what you can do? Simply you can write now. One by one you keep on writing. 1, 2, 3, 4, 6, 1, 2, 3, 4, 6, 8, right? Then 9, 12, 18, 24, 36 and 72 itself. So these are all the numbers which are divisor for 72, including 72 itself. Then now what I have to take? So d of 72 is equal to other. But what you have to write? This question asks for 7 marks, but only this one line you will remove and draw the Hasse diagram. It won't happen. So what you have to do? You have to write in theory that 1 is related to, 1 is related to. You have to write all these numbers from 2 to this thing: 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. Then 2 is related to. You have to write only even numbers: 2, 4, 6, 8, 12, 18, 24, 36, 72. Then 3 is related to all the multiple of 3. Okay, 3, 4, 6, 9, 12, 15, 18, yeah, 18 also. Then 21, 24 also. 36 also, 36, 10, 12, 3 12 are 36, right? 36, then 72. Then 4 is related to all multiples of 4. 4, 8, 12, 16 is not there, 20 is not there, yeah, 24 will come, 36 also will come, then 72. Like that, 6 I will do, 6, so 6, 12, 18, 24, 30, 36, 36, 72. Like that I will do for 8. 8 is related to 8, so 8 to the 16 is there, no, not there. 8 3 is 24, yeah, 24 is there. 36, then directly 72. I will do for 9, 9, 18, 27 not there, 36 is there, so I will do for 36, then 72, like that. For 12 I will take, I have to write again for 12. So for 12 if I have to write, so I will have 12 to the 24, 3 the 26, so for 12, 24, 36 and then 72, like that. Then for 18, for 18 I will have 18 is related to 18 itself, 36 and 72. Then I will say 36 is related to only 36 and 72, then 72 is related to 72. Like this you have to write for everything. Then you have to draw the Hasse diagram. See, for this Hasse diagram, just easiest when they give 72, draw one rectangular box like this. Okay, divide it into half, then like this. So 6 boxes are there, it is like this. Okay, let me just draw it neatly. This will come like this, this is like this, this is like this. So one by one I will start writing these numbers, 1, 2, 3. See, these are the positions. Okay, Hasse diagram rule is that whichever number, it should go only upwards. If I am writing 1, 1 will be related to all. If I am writing 2, 2 won't be related to this numbers here. Okay, 1, 2, 3. Then here 4, here 6, and here 8. But don't write 8, write 9 and write 8 here. Only one difference, this 2. Then remaining everything as is. 12 here. Okay, then here what? 18 will come here, 24 will come here, 36 will come here, and 72. Simple, right? You understood how to do the Hasse diagram for this. So that's it, nothing else is there. So this completes module 3. Then I can, how much time? See, I have taken 1 hour 41 minutes, which is equivalent to this. So I have completed 3 modules in almost half of the time. So module 4. So first, in how many ways the 26 letter of English alphabet are permuted so that none of the pattern car, dog, pun or bite occurs. Okay, so first 26 letters are there. This is very simple question. So first, how I will take? So car I will consider as A1. This whole thing I will consider as one letter. Okay. So how it will be? So my A1 is equals to, okay, A1 is equals to like this, mod A1 is equals to, so total is 26 letters minus CAR as one letter. So here in 26 what is happening? Car is removing minus one letter, minus, so minus 3 letters, and CAR is one letter, so I am adding one letter. Okay, so 26 minus is 23 plus 1, that is 24. Okay, so A1 is my 24 factorial. Similarly, A2 like this I will take, that is dog, that will also be same 24 factorial, and A3 is pun, that is also 24 factorial, same. Then A4 is BYTE, so that will be my 26 minus 4 letters. This thing is as one letter, so plus one letter, so 22 plus 1, that is 23 factorial. Same way, now I have to take, okay, I have to take A1 union or to say A2. Okay, let me just confirm it is union itself or intersection. Sorry, it is intersection, not union. Like this means what is the first? This is, wait, let me see. This is car. This is dog. So I have to take intersection, which means CARDOG. All 6 will come. So now all these 6 letters I will consider as one letter. So what will be my A1 intersection A2? This will be 26 minus 6 letters plus 1. So that is 20 plus 1, that is 21 factorial. Okay, I understood, right, how I am getting 21 factorial. Similarly, I have to do for A1 and A3 I will do. A1 and A3 also same, 3 letters, nothing is repeating. So I can say that this is equals to A1 intersection A3. Okay, then I can also say that is equals to A2 intersection A3. Okay, all are 21 factorial. But what will be my different value? So if I take A1 intersection A4, A2 intersection A4, A3 intersection A4. So A1 to A2, A1 to A3, A2 to A3, A1 to A2, A1 to A3, A2 to A3 are all 21 factorial. But this thing will become different. Why? Because we have 3 letters here, and here A4 have 4 letters. So combining there are 7 letters. So 26 minus 7, this whole will become 1 plus 1. So it will be 19 plus 1, that is 25 factorial. So I can write that these 3 all are equal to 20 factorial. Okay. Then I have to take three letters like that: A1 intersection A2 intersection A3. Then I have to take is equals to one thing. Then A1 intersection A2 intersection A4. Okay. Same way, A2 intersection A3 intersection A4. Okay, like this. So 3 possible pairs I can do, right? Distinct one. So now see here, A1 intersection A2 intersection. Okay, so A1 A2 A3 I will have, see here, car, dog, pun, and no letters are repeating here. So totally how many? 9 letters. So 26 minus how many? 9 letters plus 1, because this whole thing will become 1 letter, that is 26 minus 9 how much? So okay, so 26 minus 9 is 6, 17 plus that will become 18 factorial. Whereas if A4 is included, then that is 4 letters, so it will become 26 minus 10 plus 1, so 16 plus 1, 17 factorial. So this is also 17 factorial. Okay, and this is also 17 factorial. Okay, I will erase this and I will write here A2 intersection A3 intersection A4. Okay, then I have to find A1 intersection A2 intersection A3 intersection A4 is equals to, so here, car, dog, pun, bite. How many letters? 3, 3, 3, 6, 9, 9 plus 4, 13. So 26 minus 13 letters, right? 9 plus 4 is 13 plus 1. So 26 minus 12 you have to do, that is nothing but 14 factorial. Am I right? 14, yeah, right, 14 factorial. So I have to take for all 4 numbers: A1 intersection, A2 intersection, A3 intersection, A4. Okay, sorry, here what to say, it's one changes I have to do here. So shit man, so much mistake I did off. When I am taking A1 intersection A2, okay, we had considered car as 1 letter, right? Car as 1 letter and dog as 1 letter. So I am adding 2 here. So here it will be not 26, it will be 22. How it will be? Okay, what to say? 22. How I'll just say here. Okay, how? Because see, 26 minus, okay, A1 3 letters minus A2 3 letters plus this is 1 element, this is 1 element, so plus 2. So 26 minus 6 plus 2, that is 22 factorial. This will be, okay, even this is 22 factorial, this will become 19 factorial. Sorry for that misconvenience. So this will become, okay, similarly this will be plus 2 I have to add here, so this also will be 19. Okay, this won't be 20, this will be 21 factorial. Okay, A1 intersection A2 intersection A3. So I have to add here, this will become 20. How? Because 26 minus this is 3 letters minus this 3 letters minus this letters, then all these 3 are, this is 1 letter 1 letter 1 letter, so plus 3, so only 26 minus 6 I will get, that is 20, like that. Okay, I hope you understood, right? Let me just erase this. I have found everything. So A1 is equals to A2 is equals to A3 is equals to how much? 24 factorial. Only A4 is 23 factorial. When if I take A1 intersection A2, now see here 26 minus car is 1 and dog is 1, so 26 minus 6 plus this is 1 letter, right? We are adding that letter, so plus 2. Okay, so 26 minus 4 only is happening, so that is 24 factorial. Okay, sorry, plus minus 4 is happening, so that is 22 factorial. Understood, right? Same way, this is equals to A1 intersection A3 equals to A2 intersection A3, whereas A1 intersection A4 is equals to A2 intersection A4, which is equals to 1 less than this, it will be 21 factorial. Okay, then same way I will write A1 intersection A2 intersection A3 is equals to, okay, this. Now see here 26 minus this 3 letters in this, then 3 letters in this, plus this itself 1 letter, this is 1 letter, this is 1 letter, so plus 3 is happening. So this plus 3 minus 3 cancel, so 26 minus 6, so this is 20 factorial. Same way A1 intersection A2 intersection A4 is equals to A2 intersection A3 intersection A4, okay, which is again equal to, now see A1 A2 A4 A1 A3 A4, so this will be 1 less than this, 19 factorial. Why? Because A4 is having 4 letters, so like that I have to find now A1 intersection A2 intersection A3 intersection A4, okay, which is equals to, see now 26 minus 3 letters from this, 3 letters from this, 4 letters from this, plus 1 2 3 4, all this combined are 4 letters, so this 2 will get cancelled, plus 4 minus 4, so 26 minus 9, so 20 minus 3, that will be 17 factorial. You understood, right? So now we found all the things, so required. Now see here, this all I will say as S1, okay. I have to add all this. If I add summation of all this, I add all this, that is S1, and if I add all this, that is S2, and if I add this both, that is S3, and this is my S4. So now what they have asked us in the question, what is they have asked in the question, how many how many 26 letters of the English alphabet are permitted so that none of this pattern occur. So none of this pattern should occur, all this car, dog, pen, bike. So first I will take actual permutations. Actual permutation is nothing but see, I have to find A1 intersection, see all the see, first of all 26 letters are there. How can this 26 letter be permutated in 26 factorial ways? That is my S0, okay. So what I have to find here, I have to find in such a way that A1 intersection A2 intersection, or else I can say that A1 union A2 union A3 union A4. This is a set where all the patterns are occurring, all 4 patterns are occurring. If I take complement of this, then all the 4 patterns are not occurring. How I can write this? I can write this as A1 complement intersection A2 complement intersection A3 complement intersection A4 complement. This is equals to, say now S1 minus S1 plus S2 minus S1 S3 plus S4, okay. let me just erase this once and write properly, because I have this small board, I have to adjust, right. So okay, A1 intersection A2 intersection A3 intersection A4 is equals to S0 minus S1 plus S2 minus S3 plus S4. So my S0 is equals to 26 factorial, S1 is equals to 24 factorial plus 24 factorial plus 24 factorial plus 24 factorial, okay, then plus 23 factorial. A intersection B, A intersection C, A intersection B intersection C, A1 intersection A4, like that. Okay, understood, right? How I am having, see here, A1 intersection AB we had found, so all those things like that. Okay, then S2 will be my, now see here in the where I had found 3 I am taking. So one is 20 factorial I have, plus I have 4 sets, which is 19. So 4 times I have 19 factorial. In S3 I am taking, what to say, all 4 letters. Okay, in S1 I am taking only each one. In S2 I am taking 2 sets. Sorry, in S not like this. In S1 I am taking 1 1 1. In S2 I am taking 2 sets. Okay, sorry, wait here, I did one mistake. This is S2, right? So A1 intersection A2, like that. This is only A1, A2, A3, A2. So S2 will be my 22 factorial. How many times? I have 3 times, plus 3 times I have 21 factorial. You just see the previous notes I had written it. So I had 22 factorial. 22 factorial, here 21 factorial. So I had that A1 intersection A2, A1 intersection A3, A1 intersection A4, then A2 intersection A3, A2 intersection A4, then A3 intersection A4, like that. Totally how many? 6 were there. So like that. Then A3, 3 sets I am taking. So that I had only 1 is 20 factorial plus 4 times I had 19 factorial. Then S4 finally last what I had got, that is only 17 factorial. So this minus this thing, then I have to plus this thing, then minus this whole thing, then plus this thing. Okay, you have to just add like all the what to say factorials one by one, one by one, one by one. You can at the end you can simply write the answer also if you want, and then whatever you are getting that value. So that is your final answers. Okay, that's it, done. Wow, this is about to end, huh? Okay, I hope you understood this. Then I have defined dearrangement. Dearrangement nothing but, suppose there are n number of objects permutation of n number of objects are there. So if any one object it's not in its original place, then that is dearrangement. Okay, see now 1 2 3 4 5 it's permuted in such a way that 1 1 1 2 3 4 5. So like this we have arranged it. Now what I will do, I will just change places of one object. If I change place of this object, suppose I change like this, so what will happen? It will change 1 2 3 4 5. So everything got dearranged, right? That's what it means. Okay, so now they are saying in how many ways can each of 10 people select a glove. So there is one left glove and there is one right glove. They have to select in such a way that they won't have matching pairs. We all have like green I have, red color I have, white I have. I have to do rearrange such that each should not have matching place. So I know that if I just dearrange one side of glove, then obviously I won't have any matching glove. So that formula I have, D10 is equals to, okay, Dn is equals to, sorry, n factorial into n into, okay, let me just look into the formula here. Yeah, n factorial into, see, 1 minus 1 by 1 factorial plus 1 by 2 factorial, okay, minus 1 by 3 factorial plus so on up to plus minus 1 to the power of n divided by n factorial. Okay, this is the formula. If it is even number, I will have plus 1 by that even factorial. If it is odd number, I have minus 1 by the factorial. So now it is d10 is equals to, now see, 10 factorial into 1 minus 1 by 1 factorial. So just first write 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8, 1 by 9, 1 by 10. Then here minus, so here plus minus plus minus plus minus plus minus plus factorial 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 factorial. Now you have to calculate this whole thing in your calculator, which is equals to 10 factorial into, then see, you have to write this 1 minus 1 by 1 factorial is, this thing will get cancelled now. So I will have only 1 by, from 1 by 2 factorial you have to add all these things, and then whatever the value you will get, you have to write is equals to something, that 10 into e to the power minus 1. So don't write like this, you will get one value. Okay, just calculate and write that value, that's all, nothing else is required for that. Then I have solved the recurrence relation. Cn is equals to 3 Cn minus 1. Okay, they have given Cn is equals to 3 Cn minus 1 minus 2 Cn minus 2 for n greater than equals to 2, and they have also given C1 is equals to 5, and they have also given C2 is equals to 3. Now how I will solve this? First I will consider these values. Okay, n is equals to like that I will what to say, assume now. So now see here, let us see now this question. Here the coefficients of Cn, C1, Cn minus 1 and Cn are respectively Cn is equals to 1, Cn minus 1 is equals to 2. Okay, first Cn minus 3 into Cn minus 1, 2 into Cn minus 2. So now the coefficient of Cn is equals to 1 is there. Okay, like that I am writing. Then coefficient of this Cn minus 1, what is the coefficient of that? That is 3. And what is the coefficient of this Cn minus 2? That is 2. Okay. Therefore the characteristic equation is k square minus 3k plus 2 is equals to 0. So this is the characteristic equation, or k minus 2 into k minus 1 is equals to 0, both are same, whose roots are k1 is equals to 2, and see roots for this root, k1 is equals to 2 from this, k is equals to 1 from this, we can remove. Okay, so this is one thing you have to write, characteristic equation, this thing you have to remember. Then general solution for an is given by, okay, for Cn is equals to capital A into 2 power n plus capital B into 1 power n. Okay, this is one equation where A and B are arbitrary constants. So, A and B are arbitrary constants. Now, what I will do? I will just substitute. See, C1 is there, right? If I take n as 1, see, if I will let, now I will take n is equals to 1. C1 is equals to A into 2 power 1 into B into 1 power 1. Here I will get 2A into only B, sorry, plus only B. So, B into 1 is B itself, A into 2. This is equals to 5, C1 is equals to 5. So, I can write that 5 is equals to 2A plus B. Similarly, I can consider n as 2. So, A into 2 power 2 plus B into 1 power 2 is equals to 4A plus B is equals to 3. Okay. From equation 1 we derive this 2. So, see I have, so I can, what I can do, I can simply subtract any one place here. So, let me subtract equation 2 by equation 3. 2A plus 5 is equals plus B is equals to 5. Then here 4A plus B is equals to 3. So I have to do minus here, minus, minus, minus. 5 minus 3 is 2, b minus b, it will not come. 2 minus 4 is minus 2a. So I can say that a is equals to minus 1. Okay. From this I got a is equal to 1. If I substitute a is equals to minus 1 here, so 2 into minus 1 is minus 2 plus b is equals to 5. b is equals to 5 plus 2 is equals to 7. So a is equals to minus minus 1, b is equals to plus 7. Now I have to substitute this value in that first equation. What was that first equation? A into 2 power n plus b into 1 power n. Okay, Cn is equals to, so Cn is equals to minus 2 power n plus 7. I can write as 7 minus 2 power n. Okay. That's what they will ask in the question. Solve the, see, two ways they will ask. Either they will say only solve the recurrence relation, or they will say show that this equation is equivalent to 7 minus 2n. So how you will do like that. Then similarly, here see I have one more question. Here in how many ways one can arrange the letter C, O, R, R, E, S, P, O, N, D, E, N, T, S correspondence, so that there are exactly 2 pairs of consecutive identical letters, then 3 pairs of consecutive identical letters, then no pairs of consecutive identical letters. So first you have to like note down in this how many times C is there, how many times other letters are coming. Let us see. C is only one. Okay, let me see. 3 times how many which letter? 2 times how many letters? 1 time how many letters? So C, do you have again? No. So C is 1 time. O 1 time, 2 times. So O is 2 times. Then R 1, 2. So R is also 2 times. Then E 1 time, 2 times. So E. Then S 1 time, 1 time. So S. P 1 time, N 1 time. Then T, D is also 1 time, T is also 1 time. Okay. So now you can see here no letter has repeated 2 times. Okay. So you can see here in just a moment. Yeah, sorry, I had to. Okay, I have solved this. Then okay, this question, right? Now you can see here in how many ways one can arrange the word this. So how many ways this can be arranged now? Now see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 14 factorial divided by, see, 4 times 2 is right. 2 factorial into 2 factorial into 2 factorial, 2 factorial. 2 factorial to the power of 4 into 1 factorial to the power of 5. Whatever I get the answer over here, that is the answer for my number of arrangements. Okay. Now I have to find such a way that exactly 2 pairs of 2 consecutive letters are there. Now see here, consecutive letters how many are there? O are there, 4 pairs are there, R is there, S is there, and E is there. So to get exactly only 2 pairs, so what I have to do? I have to remove one S and I have to remove one E, so that it will become 12 factorial divided by, so 2 factorial into 2 factorial, so 2 factorial into 2 factorial into 1 factorial to the power of 7. That will be my exactly 2 consecutive, at least 3 pairs of 2 pairs of consecutive letters. Now okay, exactly 2 pairs. Now another question, second sub question, at least 3 pairs are there. At least 3 pairs means less than or equal to 3. Totally how many are there? 4. So it should be either 3 or 4. At least 3 pairs I have said. So case 1, when there are 3 consecutive pairs. Okay, case 1. So 3 consecutive pair means I will only consider one E. So in 14, among 14, one E is going. So it will be 13 factorial divided by So 3 pairs I have. So 2 factorial to the power of 3 into 1 factorial to the power of 6. Case 2, in case 2 at least 4 consecutive pairs are there. Okay, so 4 consecutive, it is same as this itself. Okay, nothing is changing. Then last, no consecutive pairs are there. So what I am doing, I will consider this all as 1 1 1 1 term. So 2 O's are 1 O, 2 R's as 1 R, and okay, 2 S as 1 S. What will become? So 14 minus 4 letters are reducing to 10 factorial divided by 1 factorial. How many times? 1 2 3 4 9 times. So only the 10 factorial is your answer for that. No consecutive identical letters. Okay, that's it. Then you have this find the root polynomial of the chessboard shown in figure. Okay, see what I said, the answers for that is actually correct itself. Okay, you can do that like that, but yeah, what I say, okay, let me just solve this question properly now. So see here, totally what to say, R 2 times, okay, one second, C O R R E S S, okay, P O N correspondence. So S has come 3 times, sorry, see how did I forget to mention that S has come 3 times. Okay, each C P D and C P D and T has come 1 time, then O R E S N has come 2 times. Okay, so so the set of all permutation of the 14 letters. Okay, so we will have, let me see the question one again, C O, okay, only one S, yeah, okay, correct itself, right. So like I said, 14 factorial divided by 2 power 2 factorial to the power of 5, that is my total number of what to say, permutations. Now let A1, A2, A3, A4, A5 be the sets of permutation in which this I am taking as A1, this I am taking as A2, this I am taking as A3, this as A4, this as A5 now. Okay, then what is the thing? So one by one I have to take now. Okay, so appears in pairs respectively. So A1 is equals to, how many times A1 is repeating? So what will happen? I will consider this as 1 letter first. So if I consider this as 1 letter, so see here, O 2 times is there, right? If I consider this as 1 letter, so 2 O's are becoming only 1 O. So 1 letter is reducing. Out of 14 letters, see 14 letters, 2 will become 1. Okay, so it will become only 13 in the sense 14 minus 2 letters, and this 2 letters becomes 1, so plus 1, that is nothing but 13 factorial divided by, now see here, 2 factorial to the power 5 is there, 5 pairs are there, now it is only 4 pairs are there. Okay, so it will be 2 factorial to the power of 4, which is equal to same this A1, what I am doing here. Okay, so A1 factorial is equals to A2 mod A2 is equals to mod A3 is equals to mod A4 is equals to mod A5. Similarly, now I have to do A1 intersection A2, A1 intersection A3, A1 intersection A4, A1 intersection A5 like that, then A2 like that, union I have to take. Okay, so all are, so I can simply say that AI intersection AJ is equals to, so now what is happening, 2 pairs, this 2 pairs, now we are what we will do, we will subtract 14 minus 4 plus 2, that is 12 factorial. 12 factorial divided by this will become 3. So same, see now I had AI mod is equals to 30. So first actual thing was 14 factorial divided by 2 factorial to the power of 5. Then if I consider AI bar, then it will be 1 is reducing, 13 factorial divided by 2 factorial to the power of 4. Similarly, ai intersection aj if I take, that's becoming, it will become 12 factorial divided by 2 factorial to the power of 3. Then same ai intersection aj intersection ak if I take, it will become 11 factorial divided by 2 factorial to the power of 2. Then if I take for ai aj ak al, okay, I j k l, that will be 1 less, 10 factorial 2 factorial to the power of 1. Then if I take all 5 I take a1 a5, then it will be only 9 factorial, okay. So these are the possible permutations we have here. So this is my S naught, okay, this is my S1, this is my S2, this is my S3, this is my S4, this is my S5. Now we will move on to the sub questions according to the numbers of permutations where there are no pairs of identical letters. So if there is no pair of identical letters, means what I will do? So S naught minus this, okay, S naught minus S1 minus S2 plus S3 minus S4 plus S5, directly I will write off, okay. For no identical letters I will say that E0 I am considering is equals to S naught minus S1 plus S2 minus S3 plus S4, like that. But also what I am doing here, I am also considering, see here, S naught is equals to n factorial, S1 is equals to C into 5 times, I am oh my god, I am explaining so badly. S naught is equals to n is equals to mod s is equals to 14 factorial divided by 2 factorial to the power of 5. Similarly, S1 is equals to, we had found that ai this one, right. So that will be is equals to 5, these are there, a1 a2 a3 4, like that, 5 comma 1 into 13 factorial divided by this factorial to 4. Then similarly if I go for S2, like that, if I go S2, this 5 is there, right, S2, same answer what you got here, 12 factorial divided by 2 factorial to the power of 3, here 5 and 2 will come, then 5 3 will come, okay, for S3 5 3, then 11 here 2 power 2, and S4 if you take 5 4, what is 4 here, S5 if you take 5 5, understood, like that you will write. So now for first, like I said, S naught E0 is equals to S naught minus S1 plus S2 minus S3 plus S4 minus S5 you have to do, that answer you have to write. For no, for what to say, where no pairs of identical letters is there, there is no pair of identical letters. So that is for no identical letters is E0. For if there is identical letters, permutations, number of permutations where there are exactly 2 pairs of identical letters, then I will take E as 2. If I take E as 2, then I will start with S2, S2 minus S3, S4, S5, okay. Then how these things will change here. Now see here, they have written 3 by 3 1 like this, and minus plus minus, here 3 1, so here 4 2, here 5 3 they are taking. This 5 3 is nothing but 5 C3, 4 C2 and 3 C1, okay. It's simple, see this 3, this 4, this 3 and this 3, 4 and 4, 5 and 5, this thing is saying 0 1 2 3, like that. Then last question they have is at least 3 they have said, right, the number of permutation where there are at least 3 pairs of identical letters. So I will take L3 is equal to, I will start from S3 minus S4 plus S5. Okay, so here 3, here 2, here 4, here 3, 4, like that they have paid here. So even I don't know exactly how it has come, just how the solution is been done. According to that I am explaining to you over here, because it has already taken a lot of time and complete so much time has gone off. Then I have solved the recurrence relation a n plus 2 minus 3 a n plus 1 plus 2 a n is equals to 0. Okay, this is one relation. They have given a1, sorry, a0 is equals to 1, a1 is equals to 6. Okay, now let us see how we will solve this. Oh wait, I think I forgot to explain root polynomial, right? Okay, wait, first let me explain this question and then I will explain that root polynomial question. Okay, the characteristic equation is, solve the recurrence relation as said, r square minus 3r plus 2. Okay, r square minus 3r plus 2, or that we in that previous sum we took k square minus 3k plus 2, right, where root was k is equals to 2 and k is equals to 1, right. So as a n is equals to, so now I have to take here a n's coefficient is 2, a n plus 1 coefficient is 3, a n plus 2 coefficient is 1. Okay, I took a coefficient like that, a n, so a n is equals to k1 into 1 power n plus k2 into 2 power n. Same that a into 2 power n plus b into 2 power 1 power n, like that same thing we are writing, front and back both are same. So now first what I will do, I will take let me take the same thing, a n is equals to a into arbitrary constant 1 power n plus b into 2 power n plus b into 1 power n. So now I will take a as 0 now. A into 2 power 0 is what, a plus b into a plus b, only a plus b I will get. Okay, a plus b should be equal to 1. If I take a is equals to 1, then 2a plus b is equals to 6. Okay, same way I got two equations. Okay, I will do now this subtraction. I will do equation 2 minus equation 1. So if I do 2a plus b is equals to 6, so I will subtract a plus b 1. So this will be, I will get 5 here, a is equals to 5 I will get. Okay, so a is equals to 5, like that I will substitute the value in this, a plus b, 5 plus b is equals to 1, so b is equals to 1 minus 5 is equals to minus 4. Okay, I got the value of a, I got value of b, then I will substitute value of a and b in this equation. So what I will get, 5 into 2 power n plus 1, okay, 1 into minus 4, 1 power n into minus 4. Okay, 1 power n, anything will always give me this n 1 itself. So 5 into 2 power n plus 4, or I can write as minus 4 plus 5 into 2 power n. Simple, right? Same as that, c is equals to, like that was there, here c is equal to this was there. So this completes what to say 4 modules now. Okay, I will take a break. Let us see the time, how much time I have taken to solve. That is 2 hours 23 minutes. Not bad, right? Still I have according to I have not paused or did something while recording. 1 or 2 places I did, but I did not study anything. So in 2 hours 23 minutes I have solved all 4 modules or options, which means 3 4s are 12, 12 into 2, 24 questions I have solved, complete paper, or including OR options I have solved here. See how fastly I did, within how many hours, 2 hours 23 minutes. So remaining still how many minutes are there, 35 minutes are there. So I will try to cover this model, what to say, 10 ABC, 9 ABC and 10 ABC in 35 minutes in next lecture. Okay, see man, it took so much lot of efforts and I'm trying to upload it as fast as possible. Please like it and subscribe it and leave it off, okay?
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.